Bismillahirrahmanirrahim. Today we will try to answer questions that you may face during the oral examination. First of all, the subject of pressure. Now, if you are entitled to give a hint about the definition of force and the force of gravity, of course, force is represented by Newton. I don't want to go to further explanation, but you must know that Newton equals kilogram per meter second, and the force of gravity is 9.81 meter per second. So simply speaking, if you rearrange this equation, you'll find that 1 Newton equals 102 gram weight. So we are shifting from Newton to gram weight. As a general rule, of course, pressure equals force over area. Of course, pressure, whenever I consider it as 1 Newton acting over an area of 1 square meter, that means that 102 acting on an area of 1 meter square, it is a very tiny pressure. So this is why I use kilopascal instead of pascal. 1 bar, of course, equals 100 kilopascal. What are the correlation between pressure and force? This may be asked by the examiner attendant. So we must also know that we have 3 or 4 examples of representing the relationship. First of all, the difficulty to inject from a syringe of 20 centimeters and that of 2 centimeters. And we'll tell the answer now, as you will be seeing later on. The second thing is the bed sores, and how can a bed sore cause ischemia and sloughing. And of course, the most important point is the pressure reducing valve or regulators, which are present on most of the anesthetic cylinders. As you can see from the explanation, of course, whenever I want to figure out the surface, I multiply the diameter by 4. So as an example of the first example, of course, if we have the 25 Newton as an example of force pressing on different types of syringe, we'll find that it will be 500 kilopascal in a 2 centimeter syringe and 100 kilopascal in a 20 milliliter syringe. So there is a great difference between both. And as we know, if I ask you what is the normal pressure of the blood pressure, the mean blood pressure will tell me 16 kilopascals. So these 2 figures are beyond, of course, this 16, and it can induce subcutaneous injection. I must consider it whenever I use infusion pumps or syringe pump. Of course, an example of the bed sores that we can consider that there is a weight of 2 kilograms of the patient as a force. Of course, you can shift it to Newton. Acting of an area of 10 centimeters over 10 centimeters. So we have a force and we have an area, we can predict the pressure. So the pressure in such circumstances will be 19.6, which is more than the 16. And now the important thing is the gauge and the absolute pressures. Gauge يعني بالعربي مقياسي. So ventilator and gas cylinder pressure, arterial blood pressure, and venous pressure readings are all gauge pressure مقياسي هم إنما actually speaking the absolute pressure of the empty cylinder as an example is about 1 bar. So for a full cylinder, if the gauge pressure is 137 bar, the absolute pressure will equal, of course, adding 1 to 137 to gain 138. So this is the difference whenever you are asked what's the difference between gauge pressure and absolute pressure. The effect of surface tension, of course, meaning that there is a tension on the surface. Tension is the force per unit length. So we will show you later on how does it look. Of course, on the surface of this liquid, the attraction between the molecules is different than that present in the depth of this liquid. As we can see that the surface will create what we call a tension over the surface. This will make droplets of water creating a sphere. This is why we have a surface tension definition you ought to know, and we will show you later on some things related to that. So whenever you are asked also about the aneroid gauge and the bellows gauge, we'll show you later on the two devices, and you can be asked about what's the meaning of differential pressure transducer. Of course, pressures that are more than 1 bar are being utilized or used to be measured by these two types of gauges. This is the explanation in figures. If suppose I get you a figure and tell you what does it mean, this is how does the first gas at the first stage regulator works. We have first and the second. Now we have a diaphragm and we have a tilted rod. The tilted rod, the downwards, there is a bulb controlling and opening, as you can see, and the diaphragm is being pushed by a spring above. And this is area where there is a high pressure from the oxygen cylinder, and this is the low pressure which goes to the anesthetic machine. So whenever the pressure is increasing, the force acting on the diaphragm definitely from upwards will be more than the one acting downwards. So the diaphragm will descend, making more opening for the gas to go through the high pressure to the low pressure. See this tilted rod. So this is the figure shown. This is second stage. I add that attached to the second stage, to the first stage, a component where you have also a diaphragm and a tilted rod. This is the tilted rod acting on an opening, and this is the first stage and the second stage. This is the demand valve. It works whenever I create a negative pressure. So pilots and people working in the fire situation use this type of regulators. This is the utilization of the decrease in the pressure of oxygen in the anesthetic machine, where the diaphragm will descend definitely because the force acting by the spring will be more than the one acting downwards. This will cause movement of the rod, opening the opening, as you can see, the rod whenever it descends, and it will create a whistling. This is sometimes in the old machines they used to listen whistling whenever the pressure is decreased. This is the gauge pressure, of course, and absolute pressure. Of course, whenever the cylinder is empty, the gauge reads zero, but inside the cylinder there is a 1 bar pressure. So whenever I want to make it zero, I must make some sort of suction. So this is different between absolute and gauge pressure. This is a hint about how does the water manometers work. Of course, we get two tubes and we try to fill it with a height of 10.2 centimeter. Never forget that is correlated to the 102 gram of equaling Newton. So we have an area downwards and an area down. Of course, this is 4 times that of the first one, and we can create knowing that's 10.2 centimeters equal to 10.2 gram of water. So 1 kilogram also equals 1 liter. So now we have a gram weight, which can be considered as a force, and we have an area. Whenever I divide both of them, I can get the pressure. The pressure will yield from this equation 10.2 gram but weight per square centimeter. So this is the weight over the area, which is considered a pressure. If you find if you want to compare the both types of manometer, you find them will be equal. This figure is considered an orthodox. So whenever I wanted to shift it to orthodox type by some shifting in the equation of 4 centimeter ought to be meter. So I put this in my consideration. So the end result that the 10.2 centimeter cubic centimeter will yield the two tubes will lead the same pressure, and then this is the point that you, whenever you find a centimeter of water, you can consider it as a weight. The 10.2 equals 10.2 gram. This is the surface tension. As you can see on the surface, the attraction between the molecules only on the downwards. Now upwards there is no attraction. Whereas the molecules in the middle are attracted by all directions. So the surface being stretched as a skin, and this is called the surface tension. What is the clinical application of it? Whenever I have a manometer, suppose as we can see in the figure, it creates a meniscus. This meniscus makes a problem whenever I want to know the level of the height of this manometer. Why does this meniscus create? It's created because the surface tension between the molecules of the liquid and between the molecules and the glass. See, this creates a concave meniscus regarding water. On the other hand, mercury creates a convex because we call it it does not wet the glass because the surface tension between the molecules are working well and good, but between the molecules and the glass cylinder does not work. This is the how can 1 kilopascal elevate the two manometers. This is water and this is mercury. Of course, it elevates it 10.2 centimeters, whereas mercury it elevates it only 7.2 millimeters. So never forget this is centimeter and this is millimeter. This is correlated also as the manometers we saw before, that this height created the pressure, but the pressure creating a height. These are the two types to measure high pressure more than 1 bar. This is what we call the boarding gauge. Boarding gauge is a hollow tube, which whenever it is stretched by pressure, this gear system is being activated, and the pointer on the scale is being activated. This is a hint about why we incline tubes, of course, to increase the accuracy of it. And this is the barometric pressure, where we create an absolute pressure where we close the tube in the upper part. The upper part cavity is called tertiary cavity, and this is the barometric to measure atmospheric pressure. And this is the other method to measure the high pressure cylinders, which we call it the pillows. As you can see, there is a pillows and there is a pressure. This pressure will activate also a gear system and pointer on the scale. This is a differential pressure transducer, where we have two sides where pressure is being applied. This will create a difference pressure between both of them, and this is what's the meaning of differential pressure. The old units you must know, in the American method use pound per inch square, pound per inch square. So 14.5 pound per inch square is 1 bar. Is 1 bar atmospheric pressure. Torr, sometimes we use the word torr. It has been on vacuum pressure gauges, and 7.5 torr is 1 kilopascal. 1 torr is about 1 millimeter mercury. So these are figures and questions you may be asked during the oral examination. I will follow you later by the other chapters. Wassalamu alaikum wa rahmatullah wa barakatuh.